So let's get going. All right, welcome back. We are Game 3001 in the summer 2021 semester at George Brown, and it's week 4, part 3 of our broadcast. This is Lab 4 that we're talking about, and today what we're going to be doing is a couple things in Lab 4. Here are the Lab 4 goals. What I want is goal 1, let's clean up the place scene, remove the obstacle, stop the starship from seeking, remove previous UI elements, create the tile class, create a grid of tiles, and show hide the grid using IMGUI. If we have time, goal 2 is let's snap our starship and target to the grid if we can. If we can't, we'll do this next week. Let's see what happens. So I already started something from last time, but we're going to start over. There is a starter that's up on Blackboard. It's called Lab 4 Starter. Lab 4 Starter is actually just Lab 3B, which is what I want to start with you guys anyway. So this is the Lab 4 Starter. Let's download this. I've already taken the liberty of doing that. And if I go to desktop, and if I go to GBC and Game 3001 and 2021, you're going to see that this is the file that I just downloaded from the starter. And Ethan, I don't want to forget the Discord link. Let's do that first. So I believe it is, let's just make a new link for you. I'm also going to share this link later on. Server settings. Invites. I think they are, I think they're expired by now. Let me make a new invite link. And I'll edit the invite link to say that it will never expire. And just temporarily, we'll generate that new link. And we'll put that in the message right here. So this is the invite link for Discord. Okay? M2021, yeah. So if you're already there, Tam, then you're good to go. But if you don't have that, I'll share this later on with everybody on Blackboard. Okay? So Ethan, that should be your Discord link when you're ready. Or did he leave? He left. Awesome. All right, I'll copy that later on. Okay, so next. So now that we're here, we're good to go. I want to expand this. I'm going to say zip 7-zip. I want to extract this. And we want to change this to Lab 4B. There it is. And get rid of this because we don't need this anymore. I want to start Lab 4B by double-clicking on the template.sln file. And what I want to do here with the template.sln file is run this. Okay, and I want to change this when it's ready to x86. And I'm going to change the solution type to retarget solution. When it's ready, C# or C++ is taking its time. And then the first thing I want to do is a couple things. I want to change the README file so it says Lab 4. And I want to also change the inside of my scenes in my playscene.cpp. I want to change the IMGUI stuff so it also says Lab 4. And then to test it, let's just run it locally and make sure things are good. And that's the first thing we should probably do, right? So that way we know everything's working. That's number 1. And if everything goes well, what we want to do is we want to put this up on GitHub immediately, right? And I'll share this as the final version. So notice I can go here, start. You can see an obstacle, and I see Lab 4 here. We need to clean this up, but first I want to use this as a baseline. So it did work. I'm going to go to Team Explorer, right? But we can't do anything with Team Explorer until we add this to solution. to source control, to GitHub. So I'm going to right click on my solution here, just like I've done before, and go to create Git repository. And then under create Git repository, we want to select George Brown College. I don't want to make it private. For you, you do. And for me, I'm going to call this GAME3001 in the summer 2021 semester. And it is Lab 4B. And I'm going to create and push. And then when this is done, I want to go back up to GitHub. And I want to go into GitHub, and we should see Lab 4B. And this is going to be our final. So I'm going to grab this link, and I'm going to go into content. And inside of content, I'm going to make a new course link. Cancel. I'm making a new web link. I'll be okay. And we're going to call this Lab 4 Final. And Lab 4 Final is going to be the thing. This is where you start, and this is where you finish. So you can compare your code to my code. That's what this is. So that way, there's no issues. No one's going to have issues between how do I start and where do I go. You can see, you can follow along here and on your own pace, try and do the same thing I'm doing. That's a great way to learn. All right, great. So that's step one. So step one, we've made a copy of our project, right? That's in here. And now let's take a look at those lab goals again. So what I want to do is clean up the placing, remove the obstacle, stop the Starship from seeking, remove the previous UI elements from IMGUI. This is the first thing that we want to do. Let's do that now. So again, one thing to note is inside of my singleton in game.cpp, I always start with the start scene. And I think just to make development quicker, we're going to not do this. We're not going to start with the start scene today. We can comment this out for now. And instead of starting with the start scene, I want to start with the play scene directly. So what this will do is just speed up our development a little bit, right? Because we don't have to go through the start scene. I'm not modifying that right now. I'm just working with the play scene, and I do this with Unity and Unreal and anything else I'm working with. I just start with the scene that I want to work with. And then I can always go back and uncomment this later on. Okay, for now, though, this is a good place to start. And that's the first thing. And again, if I was to run this to test this, you can see that clearly I start now with the play scene, but I want to get rid of this obstacle. So to do that, I'm going to go to the playscene.cpp, or playscene.h actually. And in playscene.h, I want to get rid of the obstacle reference. So goodbye obstacle. I also want to get rid of obstacle.h up here, right? And what I want to do then is when I go into my playscene.cpp, then we're going to see an error, a couple errors. So I want to get rid of the collision detection. We're not going to do collision detection anymore. As well as we wanted to get rid of the obstacle reference altogether. Let's do that. So once I've done those things, that is the first bit. I also don't want the Starship to seek. So if I run this now, it's just going to seek directly. Actually, you won't see it. You won't see it because the Starship is not enabled. It's just going to show the target, no Starship. So what I want is for the Starship to be enabled by default. So let's take this away. And if I start this off, you're going to see that the Starship is enabled. And it's going to seek towards the target. And I don't want that anymore. So to turn that off, I'm going to go to the Starship, go to definition for the Starship. And inside the Starship, probably okay, .cpp, in the update function, let's comment out the move. So it's not going to move anymore. Okay. And in my placing.cpp, I don't want to set the target position of the Starship as the target. I don't want to do that anymore because we don't need to. We don't need to do this anymore. And now when I run it, if I take the target away and I don't make the Starship move, when I kind of press play again, then it doesn't move and it shows my little Starship here and here. Okay, so I don't have to do anything with it. There's the Starship. Yay. Okay, and this isn't any good because it says toggle seek. Let's change this to toggle grid. We're going to make a grid and tile system. So let's prepare by making this toggle grid. So I'm going to refactor rename, And we're going to say that this is M_B toggle grid. My starship, it's not going to be enabled when I toggle the grid. It's always going to be enabled, and it's going to be toggle grid. That's what this is going to be. I don't need an acceleration and turn rate for now, so let's get rid of these. And I'm not going to really need to move my target in the same way, so let us get rid of this. Target position is more like going to be the goal position. And we can rename this to goal position. So refactor, rename, goal position. Because that's what it is, the goal, start and goal. And the reset button, I'm going to redo this later, so let's just get rid of all this. Okay. So that is me just cleaning things up. We also want to change the start position. So we can say that instead of speed, let's refactor rename. So refactor rename to start position. And I want to kind of do it this way. So I want to say that the start position is going to be my ship's position. And I want to make it like this, a floating goal, a start position, which is going to be kind of a position like this. I mean, I guess I could have copied pasted, but it's okay. So this is going to be the starship. And the slider float is going to be called start position. And it's going to be the start position, and then it will have the same values, 0 to 800 for both X and Y. Okay, so that I don't really have anything like this yet. I mean, I can't reposition the starship or the goal. Goal will be the target, start will be the starship, start goal, right? But for now, this is a great place to start with IMGUI, and let's run it to see what this looks like. So run. Again, all I'm doing is resetting it so we can use it for lab 4. So if I pull up IMGUI now, we can see we have toggle grid, doesn't do anything yet. We have a start position, that's wrong. Let's fix that, sorry. This should be a slider float 2, not a slider float 1. Let's try one more time. Because we want a X and Y position, like so. So I have a position for my start position, and I have a position for my goal position, and I want to be able to move these around. When I move the start, it's going to skip to the next tile, not the world position. Right now it's set to the world position, but I'm going to change these eventually to the grid position. Grid position and world position are two different things. Grid position, I'm going to have a grid that outlines in this entire area, and I want to be able to move, skip the actual objects, or fix them, or lock them, snap them, whatever you want to call them, to each of the grid tiles. All right, so that takes care of that. We've cleaned the scene. Let's put this up on GitHub. So again, I'm going to go to Home. I'm going to go to Git Changes, and I'm going to say cleaned placing, which is what we did. Commit all and push. So we've now done all of this. But I'll tell you that most of the time we're going to spend is going to be in here. This is going to be where most of our time is going to be spent, right? Cleaning up takes 2 seconds, but actually adding anything else, that takes a little bit of extra effort that we're going to use, okay? So I need to make a tile system. That's what I want to make, right? And tile and grid. And before we start, what I really want is to make a grid that looks like this. So each tile then would be a tile that looks like this, right, as an example. And let's just do this. Instead of an O, what it would look like, let's add a thing in here. It would be like So the grid would be, the tile would be looking like that. And I want there would be a status label that's going to be 99.9, right? Starting off. So it'd be something like that, that's up here, something like that. And I also have, each tile is also going to have a status label that's going to show us some kind of status code. Open, closed, impassable, and so on, right? So we can do that as well. And the status label will start off with dash dash, okay? And it should look something like this, right? When we make our label. Okay, so that's what I want for every single tile. And I want a grid of these. Remember, like we talked about here, what I want, I've shared this with you, by the way, right? This grid system. I've just got rid of all the walls in here. What I really want is a tile to be at every position on the grid, and it's going to show up when I want to and disappear when it's not in debug mode. Okay, I can turn it on and turn it off. So in order for me to do that, I'm going to have a grid that's 20 tiles wide, right? And 15 tiles high, 20 by 15. And luckily, what I've done is inside of our code, I've included additional things for you. So in our core config.h, you're going to see that I've already configured row number, column number, and tile size. All these things are ready to go for you, right? So you don't have to do anything else. Cool. Let's continue with the creating a tile class. Okay, so I don't need config yet, but let's make a new tile class. The tile class is going to be a new class that we're going to create, right? And we're going to add, initially, we're going to make the tile of type display object, but later on, we're going to make a brand new class that it can inherit from. So let's do that. So we're going to make a new tile. It's going to be a game object type. So add new item, and we're going to target instead of going into the template, it's going to go, if we click browse, it's going to browse, we're going to browse into the src folder where all our files are. Remember, that's a thing we need to do. And I'm going to click on the .h and call this tile.h. And I'm also going to, when I add that in, I'm also going to immediately add in the CPP file part. So tile.cpp. Okay. And I'm going to include tile.h. So that's the first thing I'm going to do. In the CPP or the H file, it's going to do a couple things. I'm going to make if not defined tile, then I'm going to define tile. This is our standard guard, file guard, and then endif. Okay, grid and tile. The class we're going to make, it's going to be called tile. It's going to inherit from, that's the colon, inherit from or extend a public display object for now. And when I do, resharp or C++ tells me to add in a reference to display object, which I'm pretty cool with. I'm going to make a public section and a private section like we normally do. And I also want to include our lifecycle functions here. So generate missing members. And what I want in here, these are display object lifecycle functions, right? I also want to have my constructor and my destructor. And destructor should look like this. Okay, so starting off, this is our top. Pretty straightforward. But we need some additional stuff. Our tile is going to have a few things. One of the things is, if you notice, our tile needs some neighbors. It's going to keep track of the tile above it, the tile to the left, the tile to the right, and the tile below it. So up, right, bottom. So top, basically, this is the top tile. Right, bottom, and left. And I'm going to wind our tiles in that direction. So top, right, bottom, left, just like we do when we do CSS on the web. So top, right, bottom, left. That's going to be our box model that we're going to be using. Okay. So in that case, what we need is a tile array called m_neighbor tiles, or neighbors. How about we call it neighbors? And right now we're going to hard code it to 4. But we're going to change this later on because I don't like hard coding anything. We also need a cost for the tile, as well as some kind of status. Okay, some kind of status code, right? And I also need a label, like we said, cost label. And I also need a status label. So these are all things I need for each tile. All right, and we need to use label.h for that. But the problem with using integers for status and everything else is, it'd be nice if we had a couple of enumerations to help us out, right? And we're going to get to that in a second. For example, I want really friendly names for the indices, right? I don't want 0, 1, 2, 3. I wanted the neighbor tile position for 0, 1, 2, 3. So let's make a couple of enumerations. One of them is going to be called neighbor tile. Let's do that now. So we're going to call this a new.h. It's going to be in the enumeration section, or enums. We're going to call this neighbor tile.h. Again, let's do our block, if not defined, neighbor tile, then define it. It just makes it easier. You'll see. So what I want here is an enum called neighbor tile. And what I want to think about is when I do this enumeration is what my neighbor tile will have in it. So think about a friendly name for positions of my tiles, right? Example would be something like this: top tile. We want to wind to the right, so that'll be 0. Then it'll be right tile, bottom tile, and left tile, as well as number of neighbor tiles. Why? Because if I have number of neighbor tiles, it gives me 4, and I can use that is in my array definition. So again, going back to tile.h, I could include neighbor tile.h, and if I did that, I could say that this would be number of neighbor tiles, whatever that is that happens to be. Example would be if I went into my neighbor tile.h, and then tomorrow or some other day, I want not just the top tile, but I want to do a top right tile. So let's suppose that I want to have 8 neighbors instead of just 4 neighbors. I want to keep track of the top, the right, the bottom left, plus top right, bottom left, and top left. I don't have that right now. I'm only keeping track of 4, but I could expand to 8 neighbors if I really want it to be more accurate or different, to produce different kind of pathfinding. For now, all we need is 4. So this gives me 4 tiles, which in turn allows me to define an array of up to 4 neighbors. Okay, so again, just a quick way of doing that. I also want, instead of status, I want to define status ahead of time. So what I like to do is I want to define a tile status code that I want to be able to use over and over again. So let's go and do another enumeration, a new item. I want to have a new header. We're going to call this tile status. Okay, tile status.h. We're going to do the same thing. We're going to say if not defined tile status. Then I want to define it. Again, this is all set up. There we go. And again, it's an enumeration. Right, and the tile status is going to be something like unvisited. I want to have a tile that is open or closed. I want to have impassable tiles. I want to have a goal tile and a start tile. Okay, and I could, kind of keep track of how many statuses I have, but for now, I'm going to leave that alone. This is pretty good, and now that I have a tile status, I can include it in my tile.h. So in tile.h, I can say, I want to include a tile status. So tile status, instead of me making this status of type int, I can make it of type tile status, which is more descriptive. It's a friendly name for tiles instead of an integer. Integers are not friendly. An enumeration is friendly. All right. And then going back to our tile again, what I want to think about is some of these things that I want. I haven't defined any of these things in the .cpp yet. I'm just formatting or formulating my my interface, which is the .h file. Okay, so the next part I want to think about is some getters and setters. And I want to do the following getters and setters. I want to get the tile cost and set the tile cost, get the neighbor tile and set the neighbor tile. All right. I want to get status and set status. I want to be able to do all those things. So let's start with the get neighbor tile stuff. So tile, get neighbor tile, and I want to pass in the neighbor tile itself, top, right, bottom, left, which is the position that I want to use to get it, to return. And that's going to come from my neighbors array, okay? And then I want to, we'll just do it together. I'll set the neighbor tile here, a little different than what I did before. Set neighbor tile, I will say the neighbor tile is the position that I want to set, and I want a tile pointer, which is going to be the tile that I'm going to set to that position. Okay, for now, we're not going to do that, but I want to set it up so that next week we're ready to go. I also want to get the tile cost. I'll make that a const because that's not going to change, as well as set the tile cost, which will make it a float. So some kind of floating point value. I also want to return my tile status as an integer. That's really what it's going to be, but it's in the float of a tile status enumeration variable. And I want to set the tile status as well. So some kind of tile status I'm going to use there, which is going to be status. And lastly, I want to be able to add the labels to the scene, because by default they don't get added automatically because they're sub-objects of my tile class, as well as I want to be able to set my labels enabled, if I want to enable or disable the labels as I want to. So I don't always have to have the labels like the cost and the status always enabled. So that, my friends, is my .h so far. It sounds like a lot, but really all I'm doing is I'm setting up stuff so I can display my tile properly and keep track of the cost for each tile and the status for each tile, as well as what's happening with the neighbors. I'm not going to do the neighbor stuff today. I'm just going to set the tiles up so they can display today. That's the first thing I want to do. All right, let us go up to the top, and under the tile itself, what I want is to generate definitions by declarations. I want to generate all of this, right? So all these things here. Okay, so that's like the tile destructor, the draw function, all these things, right? And then let's finish. So there we are. So again, from a destructor perspective, I want to make this default for now. In my tile constructor, I want to make the cost 0.0 to start off. because I think I'd like to initialize with that. I also want to get the status, or get the width and height, set the width and height of the tile. So again, I'm going to include my config.h. And I want to say something like, hey, I want to set width, because I can do this because they're display objects. My set width, I'm going to say that it is config tile size, this one. And I want to do the same thing with set height. So config tile size, right? So that's going to be the width and height of the tile starting off. So first things first, right? And now that I have the width and height of the tile, I can do something with it when it comes to drawing, all right? So my draw function for the tile looks a little bit different. I'm only going to draw a rectangle. So remember that what I'm going to do is what I kind of showed you guys, which is I want to draw this little rectangle for every tile when I display the tile itself, okay? In order for me to do that, I'm going to use the util function, so I'm going to include that. My util functions, one of them is called drawRect, and that's what I'm going to do here. So I'm going to say util drawRect, and I'm going to draw, starting at the get transform dot position. That's where it's going to start drawing from. It's going to be get width. This is the width of the rectangle, and get height for the height of the rectangle, and that's going to give me. It's going to draw the outer border of the tile every frame when it's enabled. Okay. The next part is I want to return the neighbor tile according to the position I get. So I'm going to say that return, right, m underscore neighbors, and I want to pass in the position. Whatever position I add in there, that is the neighbor I'm going to return, and I can make this constant. Okay. Set neighbor tile is very similar. I'm going to just say the other way around. I'm going to say that m underscore neighbors position, well, that's going to equal to tile. So basically, I'm going to say that the position, which is const, is I'm going to assign that particular index to the tile itself. So remember, there's only 4 neighbors, 0, 1, 2, 3 right now. I can make more if I want to, but whatever the position I'm going to, 0, 1, 2, or 3, I'm going to set a reference to the tile that I'm adding in there through the set tile neighbor tile method. Get tile cost and set tile cost. Well, okay, let's get the tile cost first. So I'm going to say that I want to return m underscore cost. And get tile status, well, that's pretty easy. I can return status. So those are easy to do. Return m underscore status. But, sorry, I put it in the wrong spot. I'll be okay. I meant to do it here. But setting the tile cost and setting the tile status are a little bit more involved. So let's set the tile cost first. So the way to set the tile cost is 2 things. One, we want to say that we want to keep track of the actual value of the tile. So cost is equal to cost. That's normal, and we can make that const. But then we want to display it inside of a label. And for the label, we're going to assume that the label exists for a second. And we're going to say that we want to format a string, right, to 1 decimal place. And we're going to use the string stream in order for us to do this, an IO manipulation library. So let's do that. So we're going to say include stream and include IO manip. Those 2 things I need so I can modify my strings. I can create a string. I can build a string together that has the right precision. So down in here, what I can say is let's make, and we're going to pipe in the cost that we just got from this function. So I'm creating a string here with the cost. I'm converting the cost into a string with a fixed size of 1 decimal place. And then I want to I want to make a new string called cost string that I'm going to say that is the string of the stream. Whew. And I want to say that the cost label then set text, because we can set the text of any label the way we're using the set text method to cost string. And that is how we set the tile costs, right? Similarly, we're going to do the same thing with tile status, but tile status is a little bit different because we don't have a float that we're going to convert to a string. We can do something different. So again, we want to keep track of the status. We're going to say status is equal to status. We're going to keep track of it that way. But this time, we're going to use a switch case for status, right? So what we're going to do with a switch case is now we're going to use the different cases that we get in. Well, let's make this const because we can. And the way it's going to look is case unvisited. You can see that that comes up. I'm going to say that m_status label set text, we're going to set it to that unvisited level. That's what unvisited looks like. So I haven't gone there. I don't know if it's open or closed. I've never been there before. That's what the label is going to look like. And then we're going to break. I want to do that for all the different statuses. So let's do that. So instead of unvisited, let's do open. I'm just copy pasting. So open is going to be O. I think you get what I'm doing here, hopefully. Changing the status label to match the status that I'm passing in. Closed is going to be C. Then impassable is going to be I. So I'm just coding my tile status. I'm going to show my tile status in the inside of the tile itself, right? And we're also going to do goal. The goal tile is G. And we might have others than this, as well as the start tile as S. So these are all the codes that we're going to use. So when we look at a tile, we can tell what type of tile it is. We can add other ones. So set tile status is going to do just that. Again, this is all build up for making a grid system. Without a good tile, grid system is difficult to do. Okay, now the weird parts. So we can do this one easy, set labels enabled. That's easy, we're just gonna make them enabled. So we're gonna say m_cost label set enabled to state, whatever the state is. And we're gonna make that state const. And we're gonna do the same thing with our status label. So why this? Where allows this little function allows us to set the state. I can see the label or not see the label as I please. So if I want to just hide the label, but I want to see the grid, I can do that for each tile. So I can hide and show whichever tile I want. This is a bit of control for us, which is good. The other thing is that the labels have to be added in a certain spot. By default, the way I'm making the tiles go, if I go back to this, is I'm actually drawing the tile from the top left corner. So I'm not making the tile centered. I'm actually going to draw it from this corner, which what I got to do is I got to march over half the tile, and I got to march down half the tile to start drawing the labels. I want to say I want to go, this is the center, and from there I'm going to put the label here, and I want to put the other label here. Okay, that's what I want to do. So I need to kind of keep track of an offset, right? I need to keep track of an offset. So let's do that first. So I want to say something like auto offset. That's going to equal to a GLM vec2 object that is going to be my config tile size multiplied by 0.5. And I'm going to do the same thing with the other one. So config tile size multiplied by 0.5. Let's make that an F. Otherwise, it'll be a double. We don't want that. Cool. So that is the offset. And this is kind of what we're going to use to add our labels to the tiles. So how does this work? Well, I'm going to say the m_cost label. We're going to also instantiate these things. my cost label is going to be equal to new label. And I'm going to pass in, by default, a 999 just to start off and sizing it. And we're going to make it consolas. And the label size is going to be 12. And I'm going to make it black, even though I've kind of shown you this label here, which is green. I think black is easier to see in reality. So let's leave that like that. Consolas is going to be the type. And M_ cost label, I want to get transform.position. This is where I'm going to reposition it. That's going to equal to the transform of the current tile plus my offset, which is going to, again, march over to the right and down, plus some kind of additional offset for this, which is going to be like 0.0 and 6.0. So I want to make this a negative. So what I'm saying is, hey, start off at the top left corner plus my offset. So top left corner plus this way down here, and then subtract -6. So I can put the label here first. That's what the cost label is going to be. Okay, and then I'm going to get parent. Get parent of any object allows me to get the parent that I've been added to. I can add child, M_ cost label. So I'm going to add the cost label to the parent of the object. So the parent of the tile object. So when I add the tile, then I add the cost label to that scene as well. When I add the tile to the scene is the parent, and I'm going to add the child, the cost label to that scene as well. Okay. And then I'm going to say that M_ cost label, I'm going to say that by default set enabled, I'm going to say is false. And I know we could have done this with the set labels enabled at the end, but I'm going to do it for each one. And I'm going to copy paste this. It's going to be almost identical, but instead of cost label, we're going to say that this is M_ status label. And let me just replace those things. So status label here, 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 and here. Status label. And instead of 999, it's going to start off with a status of -- because that is the default status, right? And instead of -6, it's going to be +6, which means that, again, think about this. So get transform position, that's this, march across to the offset, and then add 6 pixels. So it's going to go down here, right? That's what this is doing. All right, so that is going to make it. We're going to say that by default, this is also disabled. And that, my friends, is how we're going to be adding labels to the scene. We can't add them automatically, and I don't have a system where each object itself is a container, so we're just making it like this. And that is the majority of what we need to do for our tile system. Majority. Okay, let's see if this works by adding it to a scene, a tile to the scene, just as a test. So let's go there. So I'm going to go to the placing.h, and we're going to go into Pathfinding objects and functions. And we're going to say that tile, right? We're going to call this, did I not import that properly? Tile. We're going to say M_ tile. We're going to call this M_ tile. Let's make sure I didn't mess up there. I did not. So tile, what I'm going to do with tile is I want to print it out. So let's go now to the placing.cpp, and inside of the start method, before anything else, let's make the tile appear. So I'm going to say that here's a temp tile. I'm going to say that M_p or M_ tile. How about that? That's equal to a new tile. This is just for testing. And I'm going to say M_ tile get transform dot position. That's going to equal to a new GLM vec2 object, which is going to be in the middle of the screen at 400 and 300. And we're going to say that let's add child my tile, M_p or M_ tile. And all we should see is an empty tile in the middle of my screen. Let's see if that works and if we're good to go. And remember that this will not be centered, so it'll be slightly offset. Let's try that out. So if everything goes well, we should see this. So why is it offset down here and it's not in the middle? Because we don't want it to be centered. We want it to start at the top left corner. If I centered it, then it would be like kind of half off the screen. I don't want that. I want it to be the top left corner to be the way each of the tiles is set up. Okay, so this is correct. And if I want to show the details, let's show the details. And I can do that by doing a couple things. I can say that, hey, m_tile, and I want to add labels, and I want to m_tile set labels enabled is true. And if I did that on these two little commands, then if I run it, then you're going to see that indeed we're going to get a label with some numbers. Okay, at this point, I'm going to put this up on GitHub. We have a good tile, but before I go there, are you with me for the people that are here? Did you guys do what I did? If you are, check mark. If you're not, X. I can, very good. So why am I doing this? Why am I going so crazy? Are they all on the same layer? Yeah, I think I will put them on the same layer, I can, because this makes sense for me to do something else. The great thing is that I'm just setting it up here, which is before these ones. We can control if I want to put them on different layers. I can do a lot of stuff, right? Thank you for that feedback. All right, let's move on. Let's not do this. This was just a test, but let's put this up on GitHub. So because we have some changes, I'm going to go to my placing.h and just remove this one. And I'm going to put this up on GitHub by going to team. I'm going to go to get changes. I'm going to say added tile class. Commit all, home, and push. And that'll push everything to GitHub. So you have all of my changes up on GitHub now. You can compare your code to my code. All right, this is a great step. And what we've done here is we've created a tile class, yay, and some of its other things. We've added additional classes, helper classes as well. But what we want to do now is create a grid of tiles. Okay, how do we do that? So let's go back to a grid of tiles. So again, we're going to make some modifications to the tile class in a second. We don't need neighbor_tile.h and we don't need tile_status.h. We can get rid of these. We won't need config.h, or starship.h. I'm just chopping this down so we can have less editors up. And what I want here is inside of the placing.cpp, I want to make a new build grid function. But in order for me to do that, I need to have a grid at the beginning. How do I make a grid? There's different ways of doing it. I'm going to make it so it's a vector of tile pointers. You might want to make a array of tile pointers. I just found a vector of tile pointers a little bit easier to use. So let's do that now. So going back to this, instead of UI controls, I want to call these pathfinding objects and functions. Functionos, there we go. And the first one I want is the grid, right? So how would this look? It's going to be a standard vector of type tile pointer, which I'm going to call m_p grid. So that's the first thing. This is our grid of tiles. That's what this represents. Grid of tile pointers. Okay? We don't have a grid right now. It's just a vector and it's empty. So I need to build it up. So that's the next function. So I'm going to say that I make a new function. So we return void m_build grid. And what build grid will do will add X number of tiles to the grid based on the screen size. All right, so let's add that in. It'll be at the bottom of the placing. And what I want to do here, and this is where we're going to add some additional support for our tiles, and I'll talk about this in a second. At the bottom of the placing, when we start adding the grid, right, let's think about what we want to do. I want to, just by default, I want to keep track of my tile size. I don't want to always go config tile size every time. I don't want to do that. So I want to make an alias for tile size. Okay, that's what I want to do. And then what I want to do is I want to add tiles to the grid. So I want to use a double for loop for this. So for I, and I want to go with a row, and the max is going to be a config row num. And inside that, I want to have another for loop with column. This is a very common way of doing things, to column num. Okay, so that's kind of a row column format, X and Y coordinates, where the row number is 15 and the column number is 20, just like I said before inside of our grid system, right? All right, does that make sense? So then what I can do is I can start thinking about making a new tile. So I'm going to say, hey, tile, I want to make a new temporary tile that's equal to a new tile. Let's allocate some memory, right? So create a new empty tile. That's what we want, right? And the tile, I want to set the position of the tile. And this is the funky part, which is a GLM vec2. I want to set it to column multiplied by tile size, and then row multiplied by tile size. So that's how I want to set the tile. So when I loop through, the position of the tile is a new vector2 that's column row. At the beginning, it's 0, 0, right? Top left corner. And then I keep adding more tiles. I march across for each column, 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 column. So I actually draw the tiles this way. So one, like this. That's how I draw them with this for loop, like that way across. So that's what this does. Now what I need to do is, that is the actual, this is the world position. That sets them up, but I want to actually put them inside the grid. I could manually put it inside the grid, but I'm going to actually do a lot of other stuff with the grid. So it behooves us to make a utility class that our tile inherits from, that allows us to inherit or to use grid position. Why? Because it's not going to be tile. I'm also going to do that with my agent as well as my target. They're going to be able to add themselves to the grid as well, right? So because of that, it behooves us to make a superclass that allows us to do that. So again, I'm going to go to Solution Explorer. I'm going to right-click into, I'm going to put this new class in core because it's going to be a superclass. Right-click, I'm going to make an add, new item, and the new item is a new header, and it's going to be called some kind of pathfinding or navigation object is what I like to call it, I think. I call it a navigation object. Let's try this again. So navigation object. So that's where it's going to go, navigation object.h. And I want to make immediately a navigation object.cpp. Right? And I want to include navigation object.h. Right? And we'll do the guard. Right? And we'll make a endif. Okay. And then what we'll do is we'll do a class called navigation object, right, which inherits from display object. So this is kind of like an intermediate or intermediary class, or a middle class, if you will, a middle abstract superclass, which adds functionality ahead of us inheriting it inside of the tile system. So instead of tile going right to display object, we want tile to inherit from navigation object. We're going to give it an extra function, is what we're going to do. So navigation object is pretty much going to be a display object superclass. All right, so it's not going to be something you can instantiate. We need a constructor and a destructor. We're going to put this in the public area. And we're also going to have a private area here as well, where we have one property. Instead of using multiple inheritance, which I could, I'm not going to do that. I'm going to just use inheritance. So navigation object is going to be the destructor, and navigation object destructor. I'm also going to include stuff that I'm missing members. And this time what I want is I want to make them members like this. So what does it do? This makes it so that this is a abstract superclass. These are inherited from display object. Okay, very important to do this because then it's passed through, right? And then I want to make my object that I want to keep track of, which is the grid. I want to keep track of a position on the grid, which is going to be m underscore grid position, just a vec2 object that all of them will have. And I want some getters and setters. And the only thing that I want to get and set is the grid. So glm vec2. And I want to have the get grid position, which is going to return const, as well as set grid position, which I'm going to pass in a float column and a float row. So what this is going to convert float row and column to a vector2 object. Okay. Now, why am I doing this? Because if an object is a navigation object, I can check. I can see that I can actually do a type def, right, or type of, and I can find out if the object is a navigation object when it comes to collision detection and other things. All right, let's generate all the definitions by declarations. What we don't want is these ones. These ones are going to be overridden. So I'm going to press finish. These stay. All right, so we want to pass through this stuff. So this is default, and we want to make this default. Think about us adding just one little function to everything that inherits navigation object. But instead of multiple inheritance, we just have regular inheritance for the superclass. So what does get grid position do? Well, we return m underscore grid position. It's pretty simple. And what we want to do with set grid position is the exact same thing. So set grid position will be the same thing. We'll say that m underscore grid position is going to be a new glm vec2 object where we pass in a column and row. Okay, now you're going to like, why? What are we doing this for? You'll see. Trust me, I've gone down this path before, just a couple times. And I found that this little utility class, which is an intermediary class, actually helps us identify two things. Is it a navigation object? And it adds one little function to all classes that inherit from it. Awesome? Okay, that's fantastic. So now that I have navigation object, right? I know what this is. I can make my tile inherit from it. So this will make this navigation object instead, which means that I can inherit from navigation object, not from display object, which means that by default, all tiles are navigation objects that have a set yes, we can. Tam, that's exactly what I'm going to do later on. And isn't that like awesome? We can add additional functionality one step at a time, right? Again, there's other ways to do this. You can certainly use multiple inheritance, which is definitely supported in C++. I'm not supporting it though, because I think it can mess you up sometimes with this deadly diamond idea. All right, so let's go back and go back to our playscene.cpp and complete this stuff right here. So one thing is, it says that we have a problem with getTransform. Why is that? It says it's inaccessible. Why? Because of what we did with our navigation object.h. We need to make this public. How simple that is. One little error, and then it stops functioning. So we need to make this public, a public display object, right? Which now is okay. It makes it writable pretty much. That's what it does. Okay, cool. So now that we've got that, what we want to do is we want to continue to add to this functionality, right? So we're going to go back in here and use the new method we just made in navigation object in order for us to build the grid and set the grid position. So we're going to say that tile, this is going to keep track of the grid position in grid space. Set grid position in grid space, column row. So whatever the column row is, each tile is going to keep track of its own grid position, which is cool, right? And then next, we want to add child the tile. And then finally, we want to say that we want to add labels. So we're going to add the labels. And we're going to start off with the set enabled. All my tiles are, my tile is going to be disabled by default. My tile, my grid, each tile in the grid. And I want to push back. So I'm going to say that m_p grid, I want to push back the tile. And that, my friends, is how we're going to build up the grid. We can't see the grid right now, but let us see it. Let's just disable this so we can see the grid by default. We'll come back here and take this off. And I put this in here because I want it by default to be disabled and something we can turn on. So what we want to do is call m_grid, build grid inside of the start function. Before anything else happens, let us set up the grid. So we're going to say m_build grid. Okay, just like where we had our example tile before. Let's run this thing and see what happens. So when we go there and everything goes well, then bam, we have a grid, right? And what I want to do then is I want to be able to enable and disable the grid right through this. And we can do that now with our control. All right. I know that I also want to snap everything to grid, but for now, one step at a time, let's make it so that by default, the grid is disabled. So it's all disabled by default. And then what we want to do is we want to add additional functionality so that way we can enable the grid and disable the grid, right? And to do that, what I want is a set grid enabled function. So let's go into placing.c.h and do that. So I want to do something like void m_set grid enabled, which we're going to take in a bool state. And what I want, let's just make that generate implementation here. How will this look? Well, we're going to do a for each this time, which is a ranged for loop in C++, where the collection is m_p grid, and the element we'll call tile. The way you would read this, of course, is for each tile in the grid, do something. And what I want to do with each tile in the grid is I want to set enabled, I want to set each tile enabled according to the state that we're passing in. And I also want to set labels enabled according to the state. So right now, the labels and the tiles are connected. They're set together. I could make another function to set the labels up, enable them or disable them. For now, I'm binding them together, but I don't have to, which gives me control. The other thing I want to do is I want to say that I want to keep track of when the grid is enabled or not, right? Right now, I have a state like that. I have a m_b toggle grid, which is a UI control, right? I could say that when I turn it on, right, it's on, but I want to keep track of it in a separate file, in a separate object for now. So I'm going to say bool, and I'll say m_is_grid enabled, right? And then I'll have getter and setter functions to detect that, right? Where I is grid enabled and set grid enabled and get grid enabled kind of thing is what I want. So this is set grid enabled, right? And I want to say is grid enabled, and is grid enabled is going to return if it's true or not, right? So this is a function. And let's do that. So, but I also need I want to get, so one is a get grid enabled, and I also need a enabling Boolean. I was actually right the first time. M underscore is grid enabled. Okay, like this. So let's define it. And I may not need this later, but we're going to put it into now. I'm going to say that when I get grid enabled, it's going to return M underscore is grid enabled. And we can make this whole thing const. Let's see if I can do that. No, maybe not. I want to make it const. So the way I can do that is I have to change it on the placing.h, where I can say this is consts. There we go. All right, so that is get grid enabled and is grid enabled. So now inside of the placing.cpp, I can say that after I enable it, whatever the state is, which I can make const, I can say that that is the state that I'm gonna accept. M is grid enabled is going to be the state, whatever the state is. So when I enabled it, I'm going to check on the grid. When I disabled it, I'm going to check off the grid. I'm going to have two different flags to do that. You're going to see that in a second. Do I need all those flags? Maybe, maybe not. But this is what I found works. And these little functions are utility functions to help me with IMGUI when I can turn on and off stuff. That's what they're going to be for. Awesome. Okay, great. So let's go back up to IMGUI now and make this function, this toggle grid idea. So the way toggle grid will work, right, is when I go to the IMGUI function, what I want to do is I want to say this. When I toggle grid on and off, this will do that. It will toggle grid on off. And the way to do that is M underscore set grid enabled, and I want to pass in the M underscore B toggle grid. So I'm making it separate because this way the checkbox will show up and it'll be different than the actual M underscore P M underscore B grid enabled is grid enabled. I could make them the same. Let's test it and see if it works. So run it, and if everything goes well, then it'll enable the grid. When I click it, when I unclick it, it'll disable it based on the way it works. So again, backtick brings up this. I can toggle the grid on, and now I have all the values, and I can toggle the grid off. Okay. Again, are you with me, my friends? Check mark if you're with me. X if you're not. I can. You're with me. Yeah, I disabled it. That's all I did. So yes, yeah. So what I did was I disabled it when I built it. By default, I set enable to false. I had commented this out initially, but then I made it false initially. All right, so now that this is working, let me put this up on GitHub. So I'm gonna get Team Explorer, git changes. I'm gonna say added grid of tiles to placing. Okay, and then push that up. Push that up. What is... That's weird. Why did this not go? That was weird. It's like the changes weren't ready yet, and then I pushed them up, and there was nothing to push. Okay. Yay. Okay. Whatever happened then. All right, so great, fantastic. This is working, but when I run it, you can see clearly that I have a problem. And the problem I had is when I turn the grid on, nothing snaps. So, for example, these things here, first of all, this thing is massive. And this thing is okay, but it's not on a grid space. It's kind of in between. It's in world space, but it has no idea what the grid space is. In order for me to do that, I need to do a couple of changes. So going back to what Tam said, if I go to Solution Explorer, if I go to Agent, instead of Agent inheriting directly from Display Object, Agent can now inherit from Navigation Object, which makes more sense. So I can say that let's include Navigation Object .h, and I can change this to Navigation Object. When I do that, automatically what I get is agents are now navigation objects which have that additional function that I want them to have. Pretty awesome, right? All agents, right? And that's amazing. And they also have line of sight, they have get current heading, all that stuff that we had before. In addition to that, we have another function. And we could add them like this piecemeal to give us more functionality one thing at a time. Now, I don't want to make too many abstractions here. We already have a lot, right? It makes agents much fatter at this point as we keep on adding stuff. And this is where we may want to add multiple inheritance or use something called composition instead. Okay, but we don't want to do that right now. It just makes it easy for us to do this. And this is pretty good. So why did we do that? Well, because now what we can do when we want to snap our objects to the scene, in our place scene, I want to kind of do the same thing with our ship and our tile, right? So, I mean, I could set the grid position. I could do that. But it's like I want to be able to get a tile and set a tile. And these are a couple of functions that are missing. I want to be able to get the tile in transform position and set tile transform position. I want to be able to do that. So I don't have that functionality right now for my target and my starship. I don't have that functionality. So how do I get that? Well, in my placing now, I got to start thinking about additional things that I can do, right? So I want to add additional pathfinding functions. We talked about, it's almost like convenience functions that help us out is what I want to make. 2 convenience functions that help us translate between world space and tile space, right? World space and grid space. Okay, so how do we do that? Let's make that here. So pathfinding objects and functions here, but I want to add in convenience functions here. This is what I couldn't get to in the first lab that I did. So convenience function, I ran out of time. But we're, of course, much faster in the second half because I've already done this one time. That's why I record in the second lab, not the first lab. All right, so my convenience functions then would look like this. I want them to return tile pointers. So I'm going to say one of them is going to be a get tile. And I want to give 2 things, a column and a row position. And from my column and row position, I want to return the tile that it's pointing to inside of the grid, okay? And then I want to do the same thing with set tile. So I want to have another overload for get tile. So 2 different types of files. I can do it this way, or I can give it a GLM vec2, so 2 overloads, which is the grid position. So either column row, or I want to give it a grid position and it's going to return the tile that I want. This is a convenience function to help me, get information from the grid. Let's code them. So I want to generate an implementation and do the same thing for this one. So there's the exact same name, get tile with column row, and same name, get tile with a vector2. This is an example of overloaded function, an overloaded function, right? And this is going to make it so that we can do whatever, however we want it. If we want to use column row, we can do it. Or if we want to use a vec2, we can do that too. So how do these work out? How does that look when it comes to, the position? So one thing at a time. What I want to do is so there's two get tiles, right? So the first get tile is column row. So let's do that one first, the easiest one. So I'm going to return M_P grid. So a tile in the grid where I'm going to take the row multiplied by config column number, right? And I'm going to add to that the column offset. So what does this do? It converts, remember, instead of me using a two-dimensional array, I'm just going to basically reference the object inside the grid like this. So if I take the row, let's say, for example, and by the way, these should be const. Let's do that. Let's say, for example, I get a column that's 0. So again, let's look at this together. Column 0 is here, right? This is column 0. And then row 0. What happens with column 0, row 0? Well, these 0 out. And this is plus 0. So 0 plus 0 is just 0, which means it's this one in the grid, right? Okay, what if I get column 9 and I want to get row 4? Column 9, row 4. I want to get that position right there. How do I calculate that? Okay, cool. Column 9, so plus 9, row 4. So I take row multiplied by the column number. So row is, let's say, 4 multiplied by column number, which is 20. So 20 multiplied by 4 is 80 plus the column offset, which is 9. So 1, 2, 3, 4, right? 80 plus 9. And that gives me that little position right there. So it kind of gives me the position in the grid. That's how this works. Okay? And that's what this does. This is a little convenience function, so it stops me from doing that every single time. It's a pain for me to do that, right? And now let's do the opposite. Let's do, what if I had a grid position? So if I took a vector 2 instead of column row, I can take that in as well, either one or the other. So the way this would work is I could do an auto column, which is the grid position.x, and const auto row, which is the grid position.y. So I'm converting a vector 2 to the grid. So return M_P grid, and we're going to do the same exact thing. So this exact line here. So whether we do one or the other, it doesn't matter. In fact, one thing I could do is I could reference this one by calling this function from this function. I could do that. I'm not going to do that here because it doesn't really matter. Any questions around this? So these are just little convenience functions that allow me to get the convert, to tell me where in the grid, as an example, where exactly in the grid my object is. If I pass in a grid position, as an example, it'll return the tile from that position, whether I do column row or grid position format. Okay, so that's what these little functions allow me to do. Okay, now that I have that, okay, that's the first part. Then when I want to snap to grid, this is the next piece that I want to do, I'm working on. Let's do the next piece, okay? Not yet. Let me talk about this for a second. We're going to reset the size of the starship in a second. First things first, let's go to here. As an example, let's do the target first. So the target, the way it's going to be is, well, my transform position, instead of it being 600 by 300, I want to set it up in terms of grid size, grid tiles. Where do I want it? I want it to be, let's say, at some position on the grid, 15 and 11, let's say. So I can do that. Starting off, I can say that the target will be somewhere in the bottom right corner of the screen. So I can say that M underscore get tile, right? And I want to get tile in the row and the position of the tile. That's what I'm looking for. Give me the position of the tile, and I want to get the tile's position in the grid. So I want to say 15, 11. That's what I want the position to be, and I can continue that and say get transform. So the tiles transform position plus some kind of offset. Now the offset doesn't exist, so let's add the offset underneath build grid. So again, the offset would be, we can say that that is a GLM vec2 object, and if I'm doing this offset more than once, right, which is kind of what I've already done before, I've already have an offset somewhere. Notice that I did an offset here. I kind of did an offset somewhere else. If once I start doing an offset more than once, if I start doing this over and over again, it almost behooves me to add it somewhere. For now, though, let's not do that. I'm going to say that offset is equal to a config tile size multiplied by 0.5f and config tile size multiplied by 0.5f. So that is the offset that I'm going to use here, right? And that's the offset that I'm going to add here. So I'm going to say, hey, get the tile, 15, 11. Give me the position of the tile, and then add the offset in terms of world space. And that is the new position of my object, my target, in world space. Position in world space matches grid space. Okay? That's what I want to do here. World space matches grid space. And then what I want to do is M underscore P target. I want to say that the set grid position, now here's something. I want to be able to set the grid position of the target just like it did the, notice if I did that over here with my grid. Here's set grid position, column row. How come I can't do that with the target? Well, if I look at the target, let's go back to target, game objects. And if I look at my target.h, target.h is simply a display object. Let's change this to a navigation object. So again, it'll be navigation object. Right? And I definitely want to add that in and kind of get rid of this. It just adds an extra little function to my target. It's a very simple thing. And so now I can do set grid position to the same position of, of 1511. So that position, 1511 in the world position, I want to keep track, this target wants to keep track of itself in the grid position. So we have both things happening. I have my transform in the world position, and I also have an idea of where it lies in the grid position, which is important for pathfinding. Similarly, I want to do the same thing for my starship, but I have a problem. My starship is oversized. Eventually, I have to change the scale of my starship to match the grid size. I'm not going to do that yet. First things first, which is I want to snap it to grid, right? So again, just like it says my transform position is 200 and 300, let's change this instead of 200 and 300 and make it a grid position on the top left corner. So it's going to be a M underscore get tile, and I want to pass in 1 and 3. So the tile that's in that position, and I want to get the transform dot position plus the offset. So that is, again, position in world space matches grid space. That's what it does there. So I'm matching the position of the, I'm changing the position of the world space so it's in the middle of the grid. That's what I'm doing. All right. And then I want to keep track of that. I want to keep track of that for my starship. So I'm going to basically do M_P starship, and I want to set grid position to 1 and 3 as well. I want to keep track of that as well. And this is the function that made the starship also a navigation object. All right, that's cool, but the problem is that I need to do the same thing when it comes to my starship, right? My starship, when I move my starship, I want to I want to be able to move the starship or set the transform of the starship to a specific position based on the grid now, not on the world position. So what I want to do here is, well, first let's see if it snaps, okay, before we do the I am GUI stuff. So first things first, let's see if it snaps. Or did we mess up somewhere? Because if otherwise, there's too much going on, right? There's a lot we changed. Let's make sure it works first. And yeah, look at that, right? So if I turn on the grid, right, you can see clearly now that the starship is inside. This is inside the middle. It's right here. That's the middle of the starship, and that is the middle of the target, and they're the exact position. Look at this. They can actually tell you here the position of 16140, which is where this is, 60 and 140, right? And 620 and 460 is the position of the target. But we want this in grid space, not in world space. And the starship is really big. What we need to do is we need to make this much smaller relative to the size of our grid, which is 40 by 40, right? So how do we do that? How do we shrink this to match the grid size? Well, it's a bit of trickiness, right? So remember what we can do. We can look at the template. Let's do the starship first. So if I open the folder in File Explorer, and if I go to my assets, textures, and if I look at my starship, hover over it, it tells me that my starship is 101 by 54. So what I need to do is make this 60 by something. I could match the size, right? So how do I do it so that both are in the same scale? I could make it half the size. Half the size would make this so multiply the scale by 0.5 as an example, and then do that. Or what I can do instead is I can just modify this in a program like Fireworks. So I don't have to do it programmatically, and I recommend that, right? If you're going to use an object, you can also make the copy of this, and so make it so that there's an object that is NCL PNG, the original one, and then NCL PNG, the NCL grid, and NCL small instead of NCL large. We can do that. So let's do that. So I want to open this up, and you can open up in your favorite editor, right? I'm just going to go open with, and I have Adobe Fireworks, but you can use Adobe Illustrator or Photoshop or Paint or whatever you want. And if we do things properly here it is. Then what I can do is I can make it so that it fits within a 40 by 40 grid, right? So I can just change the scale like here. I recommend doing an asset change as opposed to a computational change because it's more computationally expensive, right? So again, we want to make it so it fits in 40 by 40, which I'm going to make it so that is something that looks like this, 40 by 21. So that is going to be the new size of my starship, 40 by 21, 40 by 21. Looks small, but that'll fit exactly inside of my grid in the exact same way. It's a lot less detailed, but that's okay. And let's do in Fireworks or other systems, you can go to Modify Canvas, and I want to trim canvas. So that makes it that the canvas is 40 by 21. But if I'm really smart, I would make this 40 by 40. So let's do 40, and I make the canvas size From the middle, I can make it also 40, which gives me space around the object like this, right, which makes it a perfect square. And that makes it much easier for me to use. I'm going to File, Save As, and what I want is for me to go into the right space. I want to call this NCL small, right? And I want to target the right location. It's got to be in the right spot. So Lab 4 Assets Textures in here, that's definitely where I want to go. And NCL small is what I want. So save. And now I have a smaller representation of my starship that I'm going to be using for my grid. And we should see it the spot. Can I refresh? There it is. There's NCL small. So it's just a smaller version that'll fit inside my grid. So why do this instead of calculate it by scale? I think it's just easier. And it's less computationally expensive. You just load the texture once. Okay. So, but we have to make a change to the starship size. So inside the starship.cpp, we'll just point to a different thing. Start NCL small. I think I did that. One more time. Let's go into open folder in File Explorer. Sorry, I just want to make sure that I did it right. Underscore. Okay, so that's what it's going to look like. Let's see what that looks like when I run it now. All right, nice and small. And when I turn the grid on, you can see that, sure enough, it's inside the grid. It fits. Make sense? Nice and easy. So we can always toggle the grid on and off, and you can see that the grid is the exact same size as the objects. And it's snapped in. Now, next part. What I want to do, and this is the final thing we'll do, is when we use IMGUI, to, by the way, I'll upload that smaller version of the NCL for you guys to do on your own if you want to, up on Blackboard. Let's do that. So before I forget, let's do that in. So I'll say build item. So we'll say NCL small texture, right? And then we'll just drag and drop that stuff in there. So we'll go into desktop, GPC, GAME3001, Lab 4, textures, NCL small. And we'll just drag and drop that in. So you have that too. So just in case you want to follow along, it's there for you. Okay? So you don't have to do any of the work. I've done it for you. Okay, cool. So going back to this then, now that I have that, I want to make it so that when I change my start position, my goal position, it changes it in grid space, not in world space. All right, so how do I do that and how does that look? Well, we want to get the grid position from the ship and from the target. So let's do that first. So instead of the position being what it is, right, as an example, the slider will be an int, not a float. So we'll say slider int. Let's change this up. So slider int 2. And it will be a int. So this is where it's going to start. And it'll be, instead of get transform position, it will be the get grid position.x. So get grid position.x, right? Because we can get the grid position. And the same thing goes with this. Nice and easy. Good convenience functions. Get grid position.y. This is why get and set grid position are awesome for us to have. So that's the start position. It's an integer. And we want to go from 0 to the column number -1. So we're going to say something like config column number, right, -1. So that'll give us a somewhere inside the grid for the start position. Then I'm going to say that if my start position, right, is 1, So if the Y position is greater than config row num, right, -1, then what I want, because I don't want it to go off screen, the start position is going to actually be equal to the config row num -1. So what this will do is it'll lock the object inside of my grid as opposed to it leaving the grid. Now what I want to do here is I want to m_get tile, and I want to get tile the m_p starship, and I want to get grid position. So whatever that grid position is, as an example, that's the get tile, and I want to, you know, well, actually, sorry, let's do that again. Maybe we'll do that next week. Starship, I want to say that get transform dot position, that's going to equal to m_get tile, right? And we're going to get tile the start position 0 and start position 1. And I want to, this is a big chain of stuff, get transform dot position. So the position of the tile is what we want, right? Plus some offset. Uh-oh. There's that funky offset again, which I don't like because we keep on adding an offset over and over again. Hey, wouldn't it be grand if we had an offset that was part of the placing? Yes, it would. We'll change that later. First, we want to make it work. So I want to grab this again. Bear with me. I know this is annoying. It is for me too, but what we want is for it to be usable first, and then we'll refactor after, right? So first, let's set the position, and then m_p starship. We will, what we want to do is set the grid position to the start position 0, and as well as the start position 1. So that sets the position. And I think this is good. This is exactly what we want to do, right? So what this does, it snaps it to grid, and when I move this around, then it moves the start position of the ship around according, and it snaps it to grid. Let's try this out and see if that works. Just this part first. So again, if I bring this up and I say, here's, look at this, 1, 3. See how I read it? And if I do this now, it can snap exactly to grid. You can see that it moves according to the grid space, not the world space, which is good. Let's do the same thing now to the goal position, right? Similar to the to what we did with the start position, I want the goal position to also be of type int. And I want to, instead of the target to do this, I want to get the get grid position dot x of the target and y of the target, right? This would be a slider int2, and its goal position, it goes from 0, and in this case, it goes to the same thing, column num. It's almost identical. And we want to make this 0, 0, as opposed to, because it's an integer, not a float. So that is the target. It's almost identical to this. In fact, it's all the same. This part's all the same, but it's just target instead of ship. So here, instead of start position, we're going to use goal position. Okay. And instead of starship, we're going to use our target. And that should be it. Let's see if that works. and 1511. I can turn on the grid, and you can see now that I can move the object, but I can't move off. Even if I go further than this, it won't allow me to, right? And I can move this up here and this down here, and it's exactly on the grid. Snap to grid. How does this look to you guys? Are you happy with this thing? What do you think? This is snap to grid. So really, in this case, we have done all of this. We've showed hide GUI. We've created a grid of tiles. We did all our primary goals as well as our secondary goals now that we've done this. Okay? Cool? Well, that's it for the lab. I'm going to put this up on GitHub. 4 screenshots for you guys, since you guys have done this with me, or even for people who are watching who weren't able to join the labs earlier. I would accept non-snapping to grid because I let the other group not snap to grid. So if you just did 2 screenshots as opposed to 3, I'm okay this time around. What I'm looking for, if you want to do the grid snapping, is for this thing to be smaller and for the grid to actually be able to toggle on and off. You should at least be able to show your grid and hide your grid. If you wanted to make this work, kind of similar to how it would look originally, it kind of looks like this, right? Where I can toggle the grid on and off. And you can see how accurate it is, right, in terms of our system now. So, and this is what we need, because now we have them on the grid, we can always do pathfinding because they're on the grid. They're not in world space anymore, they're on grid space. So pretty cool. You can move it around and check it out. I'll put this up on GitHub now, and I'll say that snapping to grid work grid. So let's go to there, Team Explorer, Git changes, commit all. I need a commit message which says added or snapped. I'll say snapped Starship and target to grid. Okay, so that's what that is. Commit all and push. And that's it for me for the lab today. Any questions before we go? I think we did a lot, and we kind of jigged everything. We're preparing for our assignment 2, and it's going to give us everything we need in order for us to be successful as a good start, a good base for assignment 2. Okay, guys, I'm going to stop YouTube now, and then I'll take questions from the people that are here. All right.